Hi everyone, welcome to Eve Math Tutoring. Today's lesson is on factoring expressions. Now before we try some examples, the question is what is a factor of an expression? So a factor of an expression are those quantities whose product is the original expression. So I'll give you an example of that. So for example, if you have the equation x squared minus 9, this the factors of this are x plus 3 and x minus 3. And the reason for that is that when we multiply x plus 3 times x minus 3, we actually end up back at this expression. Okay, so if we FOIL this using FOIL, we get x squared minus 3x plus 3x minus 9. So those cancel. So x squared minus 9. So those two actually, we get that expression. Okay, so that's basically what factors are. Now, if an expression cannot be factored any further, then it's called a prime expression. So that means it's fully factored. So some examples of prime expressions could be x. We can't factor that any further. I mean, the only other thing that would go into this is itself and 1. Okay, so x minus 3 is another one that we couldn't factor any further. And even something like x squared minus 3x plus 7. So if you actually tried to factor this, you would not be able to. So there are no two numbers that would add to negative 3 and multiply to 7 for you to go ahead and factor this further. Okay, so those are prime expressions. And if an expression is not prime and you can factor it further, then the expression is called a factorable expression. So examples of factorable expressions are, let's see here. So say you have x squared minus 9. So this could be factored further. If you have x squared plus 5x plus 6, that could be factored further. And I am going to be doing a lesson on factoring trinomials, so I'll explain to you how to factor things like this further in more detail in that lesson. But for now, if we were factoring this, we would have to think of two numbers because there's no middle term. So two numbers that would add to 0 and multiply to negative 9. So those would be positive 3 and negative 3. So we could just write this as x plus 3 and x minus 3. So that's how we would factor something like that. And I always use the AM rule. I always say AM to remember that they have two numbers to factor. You want them to add to the middle term and multiply to the last term. So in this case, the middle term is 0. Okay, so adds to 0 and multiplies to negative 9. So the two numbers would be positive 3 and negative 3. So that's how we would actually factor this further. But I am going to be doing a lesson on factoring trinomials in more detail. If I wanted to factor this, again, I would think of two numbers that add to positive 5 and multiply to positive 6. So those two numbers would be 2 and 3, positive 2 and positive 3. So I could write this as x plus 2 times x plus 3. And if I actually FOILed this, I would actually end up back at this expression. Okay, so that's how this would be factored. So it's the opposite of FOIL. So it's instead of multiplying out, you're actually factoring. You're going the opposite way. Okay, so let's see here. So when you have a common factor, it's if you want to factor something, what you're looking for is common factors. So an example could be like if you had, say you have the general like AB plus AC, okay? And so this is just a general common factor rule. So in this case, both of these can be divided by A. So you can actually factor a out, and when you do, you actually divide this by a. So ab divided by a is b, and then you divide this by a. So ac divided by a is c. And that's how you would factor. These are both equal, however, this is the factored form of the top one. Okay? So sometimes in mathematics, you could be asked to factor the expression. So let's do a few of those. Okay, let's do a few factoring examples. So say we were asked to factor the following equation. So 3x cubed minus 2x plus 5x to the 4. So what you're going to do is when you're factoring, you have to think of the biggest thing that you can factor every term by in your expression. Okay, so what I mean is each thing that's separated by a plus or minus. So you're going to look at those. You're going to think of the biggest thing that divides into here. So when I look at the numbers, the greatest common factor is 1. So there's nothing we can do further than that. Like the biggest number that would divide into these three numbers is 1. So we can't do anything with the numbers. However, when we look at our variables, when we look at x, the greatest common factor for our variables is actually x to the 1. Because that's the biggest thing that would divide into all of these. Okay, if I said x to the 2, I wouldn't be able to divide 2x by that because x to the 1 is less than x to the 2. So in this case, x to the 1 would be the greatest common factor. So what we do is go ahead and factor out x to the 1. And when we do, all you're doing is dividing each term by your factor. So 3x to the 3 divided by x is just 3x to the 2. And you know, I'm using the rules of x to the a over x to the b is equal to x to the a minus b, right? When you're dividing two things with the same base, you just subtract the exponents. So in this case, we're factoring out x to the 1. So it's x to the 3 divided by x to the 1. So it's really just x to the 3 minus 1, which is x to the 2. So that's how we get the 2, okay? Minus 2 plus 5x to the 3. That's how we divide that out of there. Okay, so x to the 1 divided x to the 4 divided by x to the 1 is just x to the 3. Okay, so that would be the fully factored form of that one. We can try another example. So say we have 3xy squared minus 9x cubed y plus 6x squared y squared. So if I wanted to factor this example, then the biggest thing I could take out is I could take out a 3 first of all. All of these 3 would be the greatest common factor for the numbers, the biggest number that divides all of those, all my 3 terms in this expression. And then for the x's, and for the variable part, the greatest common factor would be an x, and then for the y's, it would just be y to the 1. Okay, so that's the biggest power of y that I have in all 3, and x to the 1 is the smallest power of y that I have in all 3. That divides into all 3, and then over here x to the 1 is the biggest thing I could divide all of them by, and it's like the smallest power that I see in all 3, but it's the biggest thing that would divide all 3. Okay, so if I picked x to the 2, that's bigger than x to the 1, so I wouldn't be including that in my greatest common factor. So what I do is I actually factor out 3x to the y, and now I'm dividing that, so 3x cancels, I'm left with y here. Here I'm left with 3x to the 3 divided by x to the 1 is x to the 2, y divided by y just cancel, this becomes 2, sorry that's a plus, x2 divided by x to the 1 is just x, and y2 divided by y to the 1 is just y. Okay, so there would be your factored form. Okay. Okay, so we can do a few more. So it's kind of like it's actually like the opposite of multiplying is factoring. So let's try some more examples. Say you're asked to factor 3x cubed minus 6x squared y plus 9x 4y2. So in this case, the biggest thing you can factor out is 3x And the highest power for the x's would be x, I see x to the 2, so that would be x to the 2. That divides into all three. So x to the 2, and so what you're really doing for the x and y part, the variables, is you're taking the kind of like the smallest one out of all three. And even here for the y's, there's y to the 0 here, y to the 1. However, we can't really take out y here because we don't have it here. So actually, a better way to think of it would be the biggest thing that you could factor all of them by. Okay, so 3x squared. So once I do that, I get x minus 2y plus 3x squared y squared. Okay, so that would be your factor form for that one. Okay, so let's try another example. So you want to factor this one, 2x squared plus x. So the biggest thing we can take out of here is x, so then you're going to be left with 2x plus 1. Okay, so that's how you would factor something like that. And how do we get that? Well, we divided this by x, so it became 2x, and then we divide this by x, which just became 1. Okay, so let's try some more examples. Okay, let's try some where we have algebra. So if we have 1 over x plus 2 over x squared. Okay, so for something like this, so what can you factor out of here? You can factor out 1 over x. So in that case, you would just be left with 1 here, and over here you would be left with 2 over x. Okay, so, and if you multiply this back, you should end up with your original answer. So 1 over x, we would divide both of these. 1 and x, when you look at the two top parts, 1 is the biggest thing that would factor out, and over here x is the biggest one that would factor or divide both of these. So we take out 1 over x, and we're left with 1 plus 2 over x. Okay, so let's try another one. So you have x over, let's just see 1 second. So if we have x over y squared and plus x squared over y plus 2x over 3y. So if we want to factor something like this, we have, okay, we take out x over y first. So we take out x over y, and at that point, so we're looking for the biggest thing that would factor. So you're looking at it separately when you're doing fractions. So in this case, the biggest one that would divide out here would just be x, and over here the biggest one would be y. So then you're left with 1 over y plus over here x over 1 plus 2 over 3. Okay? So that would be your fully factored form. So you'd have x over y, 1 over y plus x plus 2 over 3. Okay? So that would be your answer there for this one. So let's try a few other examples. Okay, so let's try factoring the following. So you're given 3y squared plus y to the 3. So for this one, the biggest power you can take out is y to the 2, so then you're going to be left with 3 plus y. Okay. So you have x to the 5 minus 2x to the 4 plus 3x to the 3. The biggest thing you can take out of here is x to the 3, so you're going to be left with x to the 2 minus 2x plus 3. Okay, so say you have 6x minus 3y. The biggest thing you can take out of here is 3. So you're going to have 2x minus y. You have 9y minus 27xy. The biggest thing to factor out is 9 and a y. So then you have 1 minus 3x. So what you're really doing is, again, looking at the numbers, the biggest one you can factor out, the greatest common factor, so in this case that's 1. And then looking at the variables, the greatest one that would divide both of these is y to the 2. Okay? Over here, greatest common factor is 1. For the powers, the biggest one that would divide all three is x to the 3. And then when you divide, you know, when you factor out an x to the 3, you're actually dividing each of these by x to the 3. So what we're really doing to get this part is we're doing x to the 5 divided by x to the 3 minus 2x to the 4 divided by x to the 3 plus 3x to the 3 divided by x to the 3. So that's how we're reaching this. And when we do this, we use the rules of in algebra, where when you have the same base, you just subtract the exponents. Same thing here, subtract the exponents, and same thing here, you just subtract the exponents. So it's just x to the 0. Okay? So that's how we end up with that. Okay? So over here, biggest thing would be the number 3. We would go ahead and take that out. We'd be left with 2x minus y. Over here, the biggest one would be 9y, so we'd be left with 1 minus 3x. Okay, so we try a few more. Okay, let's try this one here. Say you have 5x plus y plus 15x plus y all squared. Okay, so for this one, the biggest thing you can factor out of both of these, when you look at each term in the expression, is first of all, the numbers, it's 5. Now when you look at this, the biggest one you can factor is x plus y to the power of 1. So this one's to the power of 1, this is the power of 2. So you're going to kind of look at this as one whole thing. Like, think of it like an x. Okay, when it's in brackets, just imagine it as 5x plus 15x squared. That's a trick I used to tell my students before, is just imagine this like an x, because you could have a whole bunch of stuff. You could have x plus y plus z plus, you know, y to the 2. You could have 5 plus 15 and then times x plus y plus z plus y to the 2 all to the power of 2. Right? And even in that case, you would just factor this part out to the power of 1. And this whole thing would just be one thing. So you would, in that case, you would even just factor. Actually, I can do that as a next example. Okay, so you can kind of picture it like this. So you'd factor out 5x plus y, and then when you do that inside of brackets, you're going to have this, that's just this divided by self, so that you're going to get 1 plus, and then this you're going to get 3, and then you have an x plus y left over to the 1. So again, just picturing what's inside the bracket like an x, and using the same rules for that. Okay, so that's how you would factor something like this. Now what I'm talking about up here, I'm going to actually do that for you in an example. Okay. So let's try another example. like what I'm saying is if you had x plus y plus z to the y cubed plus 15x plus y plus z to the y cubed all squared. If you were factoring something like this, it would be just like the one above, because you would think of this whole thing here, because it's the same, you could just picture it like an x. So you could just do the same thing, 5x plus 15x squared. You can picture it like that. And how would you factor something like this? Well, you would take out 5 is the greatest number that I can divide both of these by, and then in this case x. But in this case, because we have all this inside the brackets, we can just take out what we have. That's what we would factor out of those two. The largest thing you could factor, because this would be to the power of 1, this would be to the power of 2. And that's assuming it's in brackets, of course, okay? So if it is in brackets, so then you would get 1 plus 3, and then you'd get x plus y plus z plus y cubed in closed brackets like that, and then close it up like that. Okay? So that's how you would factor something like that. Okay? Let's try another example. So, let's see. So if you have something like 3 over x plus 2 over x squared minus 5 over x cubed. So in this case, what you would do is just take out 1. The biggest thing I'd take out from the top is 1, and from the bottom would just be x. So I'd be left with 3 plus 2 over x minus 5 over x squared. Okay, so that would be the biggest thing we could factor out there. What if we had something like this? 3ab squared over y cubed minus 6a squared b over y squared plus 12ab over y. So in this case, the biggest thing we could factor out would be a 3ab over y. When you do that, you would get b over y squared minus 2a over y plus 4. That's it for that part. Okay? So 3ab over y. So you'd be left with, yeah, so if you actually multiplied this back in, you would get this thing right here. So you factor out the 3ab all over y, and then you'd be left with b over y squared minus, so 6ab divided by 3ab would give you 2a, and then y squared divided by y would be y, and then 12ab over y would just give you 4. So that one would be 4. Okay. So if I want to factor something like this, that would just be 2ax would be the biggest thing I could factor out. So I'd be left with 2b plus 3ax plus 4. Okay, so that's how we would factor something like that. Okay, so that's factoring. There's a whole bunch of other examples. Let's try some with fractions. Let's do a few more with fractions. So say you have something like the following. 3 over x plus 2 over x squared minus 5 over x cubed. So if I wanted to factor this, I could take out 1 over x to the 1 would be the highest one. So I'd be left with 3 plus 2 over x minus 5 over x squared. Okay, so that would just be minus 5 over x squared. Yeah. Okay, so this would multiply in, so this would be the opposite way. So 3 plus 2 over x minus 5 over x squared. Okay, so get you another one. So if we have 5m over 2n plus 15m squared over 4n squared minus 25m3 over 8n. So if we want to factor something like this, okay, the biggest thing we could factor from the top would be 5m, and then the biggest one from the bottom would be 2n. When you do that, you'd be left with 1 plus 3m over 2n minus 5m squared over 4. Okay. 5m squared over 4, yeah, so that would be the biggest thing we could factor out from there. And that would be it for that one. So just a quick lesson on factoring. If you have any questions, feel free to email me at evemathtutoring@outlook.com, or you can post questions on the channel if you have something really complicated that you'd like me to tackle. I'm going to do a few more lessons on factoring trinomials and yeah, so I will be doing more on factoring by grouping and factoring trinomials. So this is just the intro to factoring expressions.